In everyday life, we usually use the word organic to mean a product that has been grown without the aid of fertilizers such as ammonium nitrate. In the context of chemistry, the strict definition is the enormous class of molecules that are based on carbon, and many of which are involved in the processes of life. If we take the group of molecules that are based only on carbon and hydrogen, these are called hydrocarbons. Fuels such as butane and octane and candle wax are hydrocarbons. Their molecules consist only of different numbers and arrangements of carbon and hydrogen atoms. If we widen the group to include molecules based on carbon and hydrogen, but also including oxygen, nitrogen, and a few other elements, we reach the entire class of organic molecules. And it's figuring out how to extract or make these and studying their properties that constitutes the field of organic chemistry. So, does the everyday meaning of organic make sense? Well, inorganic compounds, that is, not organic, includes all ionic compounds. So ionic fertilizers such as ammonium nitrate and potassium sulfate are not organic compounds. So it is true to say that organically farmed produce has not been fertilized with inorganic fertilizers. However, whether or not inorganic fertilizers are used, all living things are organic by nature. Almost every molecule in your body and the bodies of all organisms is based on carbon and hydrogen. And this also means that the concept of organic water makes no sense, since water is not a carbon-based molecule. In this unit, we're looking at simple organic molecules, the hydrocarbons, and a variety of other kinds of organic molecules that can be made with a few extra oxygens and nitrogens. The place to begin with all of this lies in the carbon atom. How does carbon bond? Well, remember that carbon is a non-metal and forms 4 covalent bonds. According to VSEPR, the best way to arrange 4 covalent bonds to minimize repulsion is in a tetrahedron, with a bond angle that's generally 109.5 degrees. The simplest example of this is the methane molecule, 1 carbon bonded to 4 hydrogens arranged in a tetrahedron. This ball and stick model shows you the bond angles more clearly, but the space-filling model gives you more of an idea of what the molecule would actually look like if it were large enough to see. So that's methane with 1 carbon, but it's possible to have 2 carbons joined together. Now, each carbon must form a total of 4 bonds, so we fill in the remaining bonds with hydrogen. So the formula for this compound, the next simplest hydrocarbon from methane, is C2H6, and its name is ethane. The next biggest has 3 carbons. It's called propane. The next has 4 carbons. It's called butane.